Good day, everyone. So this is another Python refresher. So in this video, we're going to review list data structure and its operations. So you have the append, clear, copy, count, extend, index, insert, pop, and remove. You also have reverse and sort. So this list of commands or operations for your list is available if you issue the command help, and you could just use the bracket, squared bracket notation to denote an empty list. And in this case, it should give you the help, and that is append. Okay, append will append the object to the end of the list, and remove all the items from your list, and then return copy returns a shallow copy of the list. Count will return the number of occurrences of a particular item in a list, and so on. So we will walk through each of these commands later on, and we will also familiarize a bit with the 1D list comprehension and compare it with the traditional list accumulation. So if you're creating or if you're populating a list with its elements. So we will also review the idea of tuples, which is just an ordered immutable collection of objects. So let's start with the list. So the list can be generalized as an ordered mutable collection of objects. So you have a first item, and the index is usually 0. So you could say that this is my item, or item, the first item. Okay, and the index for the second item will be 1. So for the second item, and 2 for my third item, and so on. So this is very similar to the other languages like C, in which, or C or Java, in which an array of objects can be represented in terms of a collection of homogeneous elements. Okay, like starting with 0, and then 1, and then 2. Okay, however, in Python, it's something more. So there are plenty of available methods, as you have seen earlier. So for a tuple, you could think of a tuple as an immutable collection of objects. So this is very similar to the list. You also have a first item, second item. Okay, but the main difference is you cannot change it. So if you have first item, second item, you cannot add, you cannot remove elements, you cannot change the existing elements, and so on. Pretty much the operations that you could do with a tuple is very limited. So we could ask for a help as well. So help of the tuple. So tuple could be represented as parentheses. And in a tuple object, okay, if you think of its default operations, so immutable sequence. So if this immutable sequence is the default, you can only count, return the number of occurrences of a particular value, and you could also check the index. So this is very limited if you compare it to the list, okay, with append, with clear, and so on. So, but the idea is they are both a collection of items in which you could access. So you have drill 1. So we already performed the first drill in this case. So use the help function to enumerate the Python list operations. So if you recall earlier, please try it in your workstation as well, in your environment. So all you have to do is to ask for help, and you could provide an empty squared bracket signifying that it's a list. So empty squared bracket. Okay, and then you will be able to list the operations as you have seen earlier. So these are the functions or the methods that you could do with the list data structure. You don't need to define them. The idea is you have simply understand the function or the output, if there is one, or what it performs. Okay, so in the next drill, so after asking for a brief documentation of the list function, okay, we could directly start with the first operation, which is the append. So if you could see, the append will simply append an object to the end of the list. So let's provide some example. So let's start with the first drill. So create an empty list and append a new items or append new items to it. So I could say, could come up with a my list. Say I have a list of strings. Okay, could be fruits, for example, mango and say apple. Okay, so I have, in this case, I could come up with a populated list. Okay, so in this case, it has 3 elements. So if I print the list, okay, if I print the list, then I will get the elements. So print my list, and in this case, this is mango, apple, and orange. But in this case, we're simply directed to create an empty list and then append the new items to it. So if we're going to reproduce this list of fruits, you have mango, apple, and orange. So you could initialize it with an empty list. So you could declare it with a squared bracket. And if you print this, okay, you will be able to see that this is an empty list. So in an empty list, you could populate the elements with the append function. You could say I will append mango first, and then append apple, and finally append orange. Okay, so if I print the list now, my list, okay, this in this case, this lists the three fruits. Okay, that is similar to the list that we have declared earlier. So you have my list, mango, apple, and orange. So in this case, we have done the creation of an empty list. So the creation of an empty list is here. So let's have this one. My list is equals to the squared bracket, and the append part will be here. Okay, so that's the first drill. Second drill, please feel free to try it as well. So in this case, create a list of objects with the bracket notation and append new items to it. So you could start with an existing list. Well, let's create another list. Say my list of, let's think of maybe Greek letters. So alpha, Okay, so omega. And this is my new list. So this is initializing an existing list. After that, we could print them, and you could append. Okay, you could add more letters, for example. Okay, let's append, say, data. And that's it. So if you print the new list, okay, then you're able to see that, yeah, indeed, the data element, okay, is added in the last item. So you might be wondering, how do we access this? So this alpha has a 0 index, and beta has an index of 1, and omega has index of 2. So this is in order. And finally, the theta has an index of 3. So you access this using the bracket notation as well. So I could print the first element, okay, with the index 0. So this will print alpha. Second element, okay, with 1. And third element with 2. And the last element with 3. Notice that if you proceed further, and this is no longer allocated to your list. So in this case, the interpreter will give you an error. So this is an index error, which is out of range. The index that you're trying to provide is out of range. So that's just how the indices are provided here. And there are additional subtlety in Python. Like you could use negative indices. So like for example, if I'm going to provide 0, this is the first element. But if you provide a negative 1, okay, you could guess what index or what element is it. So for those of you who are not familiar with Python, you will think that this will become an error, or this will give you an error. But if you notice, this is perfectly fine, and it will give you something. No index error here. So it will provide you with theta, okay, which is, if you look at our list, theta is the last element. So negative index, negative 1 in particular, will give you the last element. And from the last, omega is second to the last, so that will be negative 2. And beta is third from the last, so that will be negative 3. And lastly, alpha, which is the first element, is negative 4 from the last. So that's the idea, is it's alpha. Of course, if you move farther, this will be index error. And that's it. So you have positive indexing and negative indexing as well in Python. So next in our exercises is to create a list of numbers using the range function. So last time, if you recall, last time we have already discussed the range object in our previous refresher series. And then the idea is you could just create, so just a refresher. So let's refresh ourselves with a certain help. Okay, for the syntax. So the idea is you have a start, and then a stop, and an optional step. So if I print an object, okay, like, or a series, okay, like 1 to 5, so I could just say 1 up to 5, and then the default step third argument, the default step is actually 1. So if I print this, it will provide me with 1 to 5. Okay, or 1, 2, 3, 4 in this case. I forgot that is exclusive. So that means you have to put 1, okay, as an extra count, because this last element here, 5, will not be included in the output. So that is exclusive from the range. So this will be 5 plus 1. And if you print I, so this will be 1 to 5. Okay. So create a list of numbers using range. So in this case, although we have printed the numbers 1 to 4, 1 to 5, so this is not yet a list. So this is just printed in series or in sequence. To come up with a list, you could simply issue the constructor of the list, okay, or the typecast, if you remember the typecast notation. So this is also called a constructor. It's just a fancy way of saying that it will be constructing the list, creating or allocating the memory, and then putting the values to that memory. So if we are going to create a list from 1 to 5, for example, then you could just typecast your range object, say 1 to 5, okay, 5 plus 1, and this will give me a list. So in this case, this is already a list, 1, 2, 3, 4, 5. Of course, it's obvious that you have a typecast here. If you're still not satisfied with that, you could check the type. So the type of that variable is definitely a list, and the list is denoted by the bracket notation. So the elements are enclosed in a bracket, so that will be a list. So I will also mention that for a list, okay, list and tuples, these objects, okay, are not necessarily homogeneous. So this could be heterogeneous. Okay, so this could be heterogeneous. Okay, hetero. Okay, so this could be heterogeneous elements. So the idea is, I think I misspelled this one. Okay, as opposed to the homogeneous elements in other languages, because you need to declare the data type. So just to clarify this one, if you have my list, okay, currently the type of these elements, if you examine this, okay, these are strings, okay, str objects. So in other languages, if you declare an array, or you have the array object, okay, that means that, or you have an array list, for example, in Java, you have a specific data type, okay, that you're going to provide. However, in Python, you could simply add elements that are not the same as the existing elements. Like for example, I could have a my list, and I could append, say in this case, these are initially string. I could append maybe a number. So, okay, maybe 3.1416. Okay, I could append a floating number. I could append an integer. I could append even another list. So maybe 1, 2, 3. So I can also do that. And this is a bit surprise to some people with background on other languages, because this is different from what they're used to. So if you print the my list, okay, okay, if you print the my list, okay, you will be able to see that these in fact have different data types. So like for example, 0, 1, 2, 3, 4. So if you check the type in the fifth position, is this is actually a floating number. So float or type 0, 1, 2, 3, 4. Okay, type 4. Type 4 is 4 is an integer. Okay, you have my list in the fourth position. Okay, this is what I meant actually. So in the fourth position, this will refer to 3.1416. This one is just a literal 4, in which it is an integer, of course. So my list for 3.1416, this should be float. And 10 at position 5, that should be an integer. Okay. And lastly, in the last position, this should be a list. Okay. So I will just use the negative indexing for the last position. So this refers to 1, 2, 3, which is a list. And if you want to see that it is really 1, 2, 3, you're free to print the my list -1. So that's the one property that you could think of in a list. So it could store heterogeneous objects. Okay. I believe it's okay. And the same with tuple. Tuple also can store heterogeneous objects as well. So let's proceed. Okay, create a function. So we already did this, create a list using the range function. Create a function that returns. So in this case, we're going to create a function that returns a list of integers from 0 to n. And the n must be user input. Okay, so let's define that. So let me just call it maybe number sequence. Okay, and number n, or ask for user input. So if we ask for user input, then just okay, so returns returns a list of integers from 0 n, and then the number of n must be user input. So you could just say n is equals to, okay, so you ask for user input, say enter a or an integer. Okay, and then let's typecast this one to an integer. And we could just use the range object here. So you could just return the list of that particular range from 0. So just range of n, and then number must be 0 to n. So we must specify whether we include n. So inclusive. Okay, so if that's inclusive, so let's add 1. So for example, if we are going to call this number sequence, okay, there's stray numbers here. Anyway, so let's run this one. Number sequence, enter an integer. Okay, say I have an integer 1 to 5. okay, or 0 to 5 in this case. So indeed, it returns a list, okay, from 0 to 5. So that's the idea here. This one, just disregard 1 to 10. Maybe this is a stray lines of code that I've included earlier. Okay, so that's accept or returns a list of integers from 0 to n. The number n must be user input. Okay, so that's the solution here. The number n must be a user input. So next, by the way, an alternative solution, you could think of another solution. Maybe this is, I could call this solution 1, and then this is solution 2. So instead of doing the construction of a list, one alternative approach or the traditional approach is you could come up with an empty list. Okay, like the result is an empty list, and then you could simply iterate. So you could also iterate in a list for I in this particular range, and within this iteration, all you have to do is to append, like append it to the empty list. So result that append the number, okay, and it should produce the same thing. Okay, so if I call this function, okay, let's run this definition first. So if I call number sequence 2, it should ask me for an integer, say 1 to 8 this time, or 0 to 8. And in that case, it still gives me the list of numbers. So this one is the approach that is also common when you start with an empty list and then just iterate through the numbers and adding the numbers. So I will teach you the other format later on, or we could just discuss the last approach. Okay, another approach will be the what is called as the list comprehension. So list comprehension is a definite format. So for example, using list comprehension. Okay, in a list comprehension is you will use the bracket notation, which is the list, and then whatever expression, okay, expression, and then the for loop. And if you have a condition, you could also use a condition, which is optional. Okay, so in that case, if we're going to use the list comprehension here in this third function or alternative solution, I could simply return, okay, expression. In this case, the expression, if you look at the for loop, the expression is just the element itself. This one, I. So you could just say I, which is the number, and the for loop. Okay, so you could just copy the for loop there. And pretty much that's it, because in this case, we don't have condition. So Python will consider this as a list. Okay, so list comprehension. And again, this is the expression. This is the for loop. Okay, and since the condition is optional, so the condition is not here. Okay, so this is a very simple one-dimensional list comprehension. Okay. So let's clear this and let's try this number sequence tree. Wait. Okay, so in this case, n is not defined. Okay, so let's just copy the input. Okay, and run this again. So let's run number sequence tree again. Okay, so let's input an integer, say 9, this guy, 10. Let's try 10. So it's have 0 to 10. And as you could see, it still produces the list. So if you are going to investigate the type here, this is actually this is actually a list. So integers 5, and the data type here is a list. Okay, so pretty much this is it for the list comprehension solution. Again, just to review, the format for your list comprehension is an expression. So it could be I in this case, as simple as that. Or you could have 2 times I or I squared. Okay, and then for I in range, this is the for loop. So the advantage of list comprehension is the syntax is more compact, and in some cases it runs better than the existing traditional way of doing it. Okay, so let's try the next drill. So in this case, create a function that accepts a list of integers and returns a list of squares. Okay, so in this case, we could try it for our multiple methods. So I could use the traditional append style format. Okay, so you could just name this maybe squares. Okay, let's just call this squares 1. And the problem here is create a function that accepts a list of integers and returns a list of squares. Okay, so this squares function will return a list of squares of given elements. So we have a um, input list. Okay, so you could just call this a in list, or let me just call this input list. Okay, so the input list, we usually iterate the elements in your input list, and the same pattern could apply. You could still have an empty list for the storage of the result. And in this case, we're going to square. Okay, we're going to square the elements of the input list and return the list. Okay, so let me trace the 1 to 10 just to get rid of this. Maybe this one. Okay, so I believe that's the one. Look at we. Okay, now it's clear. So sequence. Okay, let's try the function squares 1, and let me input a list, maybe 1 2 3. So what I'm expecting here is to get a 1 4 and 9. Okay, because that will be the square of 1 is 1, square of 2 is 4, and square of 3 is 9. And indeed, we got it. So you could extend it to 4, 5, 6, 7, 8, 9. And we got the output squares. So we have an alternate approach or alternative approach. We could use list comprehension instead of the traditional iteration or traditional loop. So in this method, okay, what we're going to do is simply return the list, and the expression here is just I squared, if you recall. Okay, just recall here, the expression for the elements is the square of the items. Okay, and the for loop, so for I in range, or this is in input list, the elements in your input list, and squares 2. Let's run this, and let's run squares 2. Okay, let's put same elements 1, 2, 3, and it's also give you 149 as before. So 4, 5, 6, 7, 8, 9. And indeed, the list comprehension here works. So this is simple one-dimensional list comprehension. You could also extend list comprehension to two-dimensional. But for now, our goal is just to introduce lists and one-dimensional list comprehensions. So we did create the function which accepts a list of integers and returns a list of squares. For the next drill, create a function that accepts a number and returns the sum of its digits. So in this case, accepts a number and returns the sum of its digits. So like for example, if I have 1, 2, 3, then the sum of the digits will be 1 plus 2 plus 3. So that in that case, that will be 6. Okay, so in that case, we could come up with first the list of the digits. So we could come up with, so let's just make this a function. So def sum digits. Okay, so in this case, we have an input number, and this function, okay, will return the sum of digits. Returns the sum of digits of n. So one way to go about this problem is to separate first. Okay, you could separate. So if this 1, 2, 3, you have to find a way to separate the digits. Like 3, separate the 3, separate 2, and separate 1. So way back before, we discussed a convenient operation like the modulo. Like if you have an n which is 1, 2, 3, if you have, say, you could think of a while loop. So while n could be greater than 0. Okay, while n is greater than 0, okay, you could update, you could get the modulo. So let's say print the remainder of n if divided by 10. And then you could update your n by dividing it with uh, 10, for example. So update the n by dividing it with 10. So the first number that will be printed, modulo 10, will be 3. And then after that, it will be divided by 10. So what remains will be 12, if I'm reading this right. And then after that, it will it will it will print 2, and finally it should print 1. So let's see if it indeed, okay. So it behaves as expected. So the idea is the first digit that it provided is the modulo when it's divided by 10. So it's 3. And then we updated the n. Okay, so the n will become 12. That is 123 divided by 10 is 12.3. And we're just interested with the whole number. That's why we did an integer division. And after that, 12 modulo 10 will give you 2, and so on. Okay, so we could use this pattern. Okay, could use this pattern, and then instead of just printing, I could put it in a total accumulation. So let me have total will initially be 0, and you could say that total will be the accumulation of the remainders or the digits. And after that, we're going to update, okay, your n. And once that's completed, okay, we're going to return the result. So we're going to return the total. Return the total. Okay, so the logic here is we have here the container for your result, which is total, and it will continue accumulating the sum of the digits. So like the example here in the interactive shell, we printed the digits. You have 3, you have 2, you have 1, and so on. So, and then instead of printing it, we simply accumulate it with a total. So this is very similar to the accumulation of a list. So when you're accumulating a list, we use the append, okay, but without, in this case, the output is just an integer. We're just getting the total of the digits. So in this case, we are simply accumulating whatever is the sum. And you need to update, okay, you need to update the current number. Otherwise, if you do not update this, our while loop will not terminate. Okay, so let's try this function. Let's try this with, okay, some digits. Maybe 1, 2, 3, 4, 5, 6. So what's the sum here? So this will be 15 plus 6 or 21. So this should be 21. And it is. So 21 plus 7, this should be 28. Plus 8, this should be 36. Plus 9, this should be 45. And that's it. So I believe we have tested it. Sum of the digits. Okay, so returns the sum of the digits of the input n. So we could also have an alternative solution. One alternative solution, okay, that some people will suggest is instead of manipulating this mathematically with the remainder, remember modulo is just the remainder, you could also convert it directly into, I think it's, you could convert it into a string. So this integer, if you think about this is an integer, and you could convert it into a string. And then after converting it into a string, you could, okay, after convert it into a string, you could just get the total. But it's still a string. So you could have the digits separately. You could separate the digits. Like for example, x is equals to 1, 2, 3, 4. So if I convert it into a string, and then I will convert it into a list. Okay. And you could okay, but in this case these are strings, so you cannot get the sum. So you could say, if we get the sum, okay, so as expected, this is not yet in an integer. So okay, this concept is a bit advanced, so I will not um, give a details on this, but you could come up with a map. So in this case, we're just mapping it with, we're just typecasting it into an integer. Okay, because you cannot get the sum of strings. It will be an unsupported operand, as you have seen here. So an alternative solution is you could typecast all of those strings into an integer. And let's just check the parentheses here. Okay, we lack one more parenthesis. Okay, the parentheses are enough. And this should provide me the total, which is 10. 1 plus 2 plus 3 plus 4. And indeed it get me the total of the digits. Okay, however, this might not be that friendly for beginners. So I believe this solution is still simpler when you are using the digits. Okay, just getting the modulo of the number to extract the digits. Okay, but let me just write this, okay, as an alternative. Okay, and you could ask the help on map if you're not familiar with the function. So the map basically will make an iterator that computes the function using argument from each of the iterables. So it's like distributing the typecast, okay, the function int, okay, to the elements of your string, or to the elements of your list, okay, or to the digits. So the first one, the string of x, will convert your integer into a string. So from 1, 2, 3 integer into a 1, 2, 3 string. And the list, okay, will make it a sequence of elements or digits. And but you cannot add it because they are strings. You need to typecast it with an int. So this is an alternative solution. Okay, so let's just make this 2, and let's test the second solution. So what if we have 1, 2, 3, 4, 5, 6, 7, 8, 9? If I recall correctly, this is 45. Okay, x is not defined. So, okay, so this is 45. Indeed, it is 45. Okay, so that's it for that. Okay. For the last one, for the last drill, at least for this section, create a function that accepts a string and returns a list of characters. So string and list of characters. So in this case, this is accepts a string and returns a list of characters. So you could convert a string, okay, like for example, a name. Okay, you could return a list of characters. So you could simply use the string a list of characters. So you could use the list typecast here. So list of name, okay, will give you the list of characters. And in the same manner, you could access the first one with 0, second one with 1, and so on. So basically this letter G is just typecasting. So this is very similar to the earlier, okay, like if you have a digit, sequence of digit. So let me just call this digits, and we could simply produce the lists of digits. Okay, and I could assign this to a variable, say my list, and I could access the first element. Okay, in this case, at least the first element is 1. Okay, the last element, okay, which is 9, and so on. So create a function that accepts a string, okay, and returns a list of the string characters. Okay, this is merely typecasting. So diff convert to list. So convert to list accepts a string. So say input string. So all you have to do is to return a list of characters. Just return it. So return the list. Uh, the list form of your input string. That's it. Simple as that. So convert. I could say, okay, I could have okay, so we could have characters list of A, B, C, D, and in this case, it will be convert to list is not defined. Let's run this first. Okay, and in this case, we have a list A, B, C, D. Okay, so this is the answer to the last drill of this particular section. Okay, more list comprehension, perhaps we could add more. Okay, list of integers. So how about let's create, okay, create instead of just a list of integers, just create that accepts the list of integers and returns the squares. How about returns the list of even. Okay, how about let's just return the even squares of the given element. So again, you could feel free to post the video and you try this problem yourself. Okay, what if instead of just returning, okay, the squares, how about you try to filter it out with the even squares? Just return the even, okay, not the odd squares. So 9 will not be returned. So 4 will be returned, and so on. Okay, so let's solve this. Okay, return the even squares. Okay, I could use, let's just use the traditional for that. So first, the traditional will be the even squares. Okay, returns a list of the even squares, a given element. So in this case, if just have to add a condition. So if this square, okay, modulo 2 is 0, so that's even. Okay, if the square modulo 2 is even, okay, then you will append. Otherwise, you do nothing. So this is the traditional solution without the list comprehension. Let's try this with 1, 2, 3, 4, 5, 6. So as we might expect, 1 will not be returned because 1 is not even, or 1 squared is not even. So 2 squared, 4 is even, so that will be returned. 3 squared will not be returned, so 4 squared will be returned, and 6 squared as well. Okay, so 4, 16, and 36. Okay, so that's the traditional solution. Okay, you could also do a list comprehension for this. So in this case, this involves condition now. So returns a list. So this one is using list comprehension. And in that case, okay, the expression here is still I squared. So you will simply return I squared. Okay, and then the for loop. So for I in input list, and the condition. So if modulo, okay, if I squared modulo 2 is 0. So let's try this second solution. Again, this I squared, this is the expression. Let's just comment this out just to clarify for everyone. So this one is for your expression. Okay, and the second one is the for loop. Okay, and lastly is the condition, which is optional. And in this case, it's needed to filter out the even numbers or the even squares. Okay, so let's run this. And even squares. So even squares 2. Okay, let's produce 1, 2, 3, 4, 5, 6. Okay, so this one should return 4, 16, 30, 16, 6 squared 36, and 64. Okay, and indeed the list comprehension solution is very fast in this case. So just the same, okay, just same behavior with the traditional solution, okay, but in one line. Okay, so I believe that's it for this section. We have introduced the basic lists and list comprehensions, the creation, okay, not so with the access, okay, although let's introduce more the access. So if you want to access these elements, let's assign this to variable, like this is my number list. Okay, these are my numbers, for example. And if you print the numbers, okay, the numbers here are 4, 16, and 34, 36, and 64. So you could access the first element, okay, access the second element, access third, and access last. Okay, so wait, the last element is, so the third element is 2, okay, and the last element is 3. Okay, because remember that the numbers, index for the numbers started at 0. So 4 has 0 index, and 16 has 1, 36, 2, and 64, 3. 4, this is already out of range. So numbers 4 is already an index error because it's no longer part of your data structure. Okay, because your data structure is just allocated for 0, 1, 2, and 3. Okay, so that's it for that section. Let's proceed to the next. Okay, next one is clear. So the idea with clear is it removes all of the items in your list. Okay, so use clear operation to empty the list and differentiate clear with the del method or del function in Python. So let's start with an existing list. So numbers, you have 4, 16, 36, and 64. If you want to get rid of these elements, all you need to do is to issue the command clear. Okay, and if you print numbers now, okay, it will already be an empty list. So an empty list is signified by the empty bracket, empty squared bracket. So differentiate it with the del operator. So say I have this another list, okay, another list of numbers, and this contains 4, 16, 36, and 64. If I use delete, okay, delete this another list. Okay, if you notice that this will remove the variable, and if I call another list, okay, then it will no longer be existing. So it's no longer existing in our interpreter. So the interpreter will no longer recognize it as a valid variable. So the delete will basically remove that particular variable. However, the clear, if you notice for the numbers, okay, we could still call that variable, only that it is empty. So the clear operation will empty that list, but you could still access the variable. So that means if you want to append, okay, maybe a new element, maybe a new number, Okay, say 99. In this case, 99 should be, okay, numbers. I think it should be there. But this is in interactive shell. Maybe there are some issues. Okay, so let's put this in the script. So numbers, okay, is equals to, let's just put some initial 1, 2, 3. Okay, and then after that we clear numbers that clear, and then we print, okay, the numbers. So in this case it will give me an empty. So print the numbers first before clearing it. Okay, and in this case, before clearing it, it has contents 1, 2, 3. After clearing it, it's already empty, but still you could add elements there. So number that append, and I could put 99, and if I print numbers, it will, okay, it will already contain the 99. Okay, here. So initially 1, 2, 3. Okay, then after clear, it's empty, and after it became empty, I could still append. Okay. However, that is not the case if I delete. So if I issue the command delete of this variable, it will be removed, and my numbers can no longer be accessed. Okay, I can no longer append. So if I run this, this will already be an error because numbers has been deleted and it's no longer defined. So we only use delete if you no longer want to use that particular variable. Okay, so if you just want to empty the variable, then you could use clear. Okay, copy. So you could also copy the elements of a list. Okay, differentiate the shallow and deep copy in Python. So the shallow copies in Python only copy the references to elements. What does that mean? Okay, like for example, if I have a list 1, okay, let's have a list 1, maybe just contains 1, 2, 3. Okay, and if I have another list, okay, which is the copy of that list, so list 1 copy, okay, if I print this list, okay, the elements are exactly the same. Okay, so if I check the ID, because the reference could be represented by an ID, so their ID will be similar. So the ID of, say, the first element in the first list, okay, list 1, first element 0. Okay, the ID is the memory address, so 140 and so on, 744. Okay, for list 2, you will expect that this is the same. Okay, so that means they're just referring to the same item. Although they're different object, list 1 is a different object than list 2. Okay, the elements that is contained there are, okay, are just having the same reference. Okay, so the complications here will, this is, by the way, this is what you call as a shallow copy. Okay, so shallow copies, they only copy the reference to the elements of the original list. So if you really want um, a new object, okay, within the elements, then you need a deep copy in that case. So you could just use the copy module. So you could say, let's just put this here. You could import the copy module. Okay, and then if I have a list one, okay, say I have 1, 2, 3. Okay, list 2 is just a copy, shallow copy, for example. So list 1 that copy. Okay, let's come up with a deep copy. So in the third list, okay, let's use the copy module to come up with a deep copy of list 1. Okay, and let's compare. So let's print the ID. Okay, let's print the list 1. This is the original. So first element, for example, and let's just print the ID or the memory address. Okay, and the next for the list 2. So what is expected here is list 1 and list 2 will have the same ID, or they have the same memory address. Okay, because list 2 is just a shallow copy. Okay, and shallow copy, you have the same address or the same ID. Okay, so the third one, which is the list 3, okay, this is a deep copy, so it should have a different. So this one is the original, the first one. Second one is a shallow copy, the first element in the shallow copy. And the third one is a deep copy. So the only different address here will be the last one, the third one. So this should be a different number. Okay. So let me present this in an interesting manner. So let's put okay, ID 1. Okay, let's just put ID 1 here and ID 2. So in the ID 1 and ID 2, okay, they must be the same because it's a shallow copy. The only different ID here will be the ID 3. Okay, the last ID will be different. Okay, so let's show this one by running this. Okay, so if you notice, so ID 3, wait, okay. So in this case, since I'm just copying an immutable, okay, they are just having the same address, okay, because 1, 2, 3 is an immutable object. Okay, but let me replace this with a mutable object. Mutable object, which is another list, okay, like A, B, and C. So if this is another list, okay, in this case, okay, this will provide me with a different address. Okay, so let's run this again. Okay, so as expected, the first one is the original. The second one is a shallow copy. And the last one is a deep copy. As you could see here, the deep copy is different. Okay, different than the original. So you might say that, sir, what's the difference here? What's the difference between a shallow copy and a deep copy? Okay, so you have shown that the ID are different. Okay, the shallow copy being the same as the original, and the deep copy being different than the original. What's the implication here? So, well, the implication is if I change Okay, like for example, in my list 2, this is a shallow copy, right? So in my list 2, okay, if I change the first element, okay, maybe I could add, okay, since the first element is a list, maybe I could append another letter, maybe X. So if I could append another letter X, okay, so if I print, okay, if I print the list 2 now, okay, I already appended X in the first element, which is the list. So the list now becomes A, B, C, and X. So since this is a shallow copy, okay, list 2 is a shallow copy, then it will affect the original. So if I print the original, okay, list 1 is the original, remember? So this original list will now contain the X, okay, that I just appended in list 2, since they are referring to the same address. Okay, look at the address. It's the same number. List 1 will also change. Okay, so it should, if I print this, it should also show me the X that was appended in list 2. Okay, and it did. Now you might say that, sir, I did not append X in list 1. Okay, well, you didn't, but they have the same reference with the element in list 2. So that's the idea of a shallow copy. It's not really an independent element. The element there is just a reference to the original. That's why they have the same address. Okay, however, if you look at the list 3, okay, which is a deep copy, if you recall, list 3 will be independent. So it's not affected here. Okay, even if I change list 3, okay, to maybe I will append, okay, maybe a different letter or just a string, okay, deep copy. Okay, so I will append a string in the independent list, which is the list 3. And if I print the list 3, okay, it will have a deep copy in this case. Okay, however, because list 3 has a different address, okay, this append will not affect the original list. So the original list will still give me the old one, okay, ABC, without the deep copy. Okay, so if it is a shallow copy, that means it's not independent to the original list, because the element there is just a reference to the original list. Okay, however, as you might have seen earlier, if you're just dealing with immutable objects like 1, 2, 3, a set of integers or a list of integers, okay, then it doesn't matter a lot if you're making a shallow copy, because for example, list 1, if I'm making a shallow copy of just 1, 2, 3, and then my list 2, okay, my shallow copy is list 1. Okay, in this shallow copy, it will not affect that much. So if I print shallow, okay, it's 1, 2, 3. And since 1 is immutable, if I replace it with 10 or 100, just to be different, and print the shallow now, it's 102, 3. Okay, but this will not affect the original. So the original list 1 would still be 1, 2, 3. Okay? You might say that, sir, why is that? Because we are dealing here with immutable object. If you look at the ID, okay, the ID here of the shallow is already different than the list one ID, or shallow, the ID of shallow 0, the first element. Okay, this is already different than your original, which is the list one. Okay. Why the difference? Because if an immutable object is replaced, it will create another object. So this problem will only occur, okay, if you have a mutable object. So if you have a mutable object and you plan to be independent with the existing, okay, then try to make a deep copy of that particular list. Okay, so that's the difference. A shallow copy, again, is dependent to the original, or they are interlinked. Okay, they're interlinked because the elements in a shallow copy is a reference to the original. Okay, so I hope that's clear. Okay, so next, the count. So count will simply return the number of occurrences of the items in a list. So this is a very simple demo. So if I have a list, and let's just go with the numbers, maybe 1, 3, 3, 5, 5, 6, 7, 8. Okay, so I could just count here. So my list, that count, okay, I could count the eights, and it will return 3 in this case. It's just counting the occurrence of that particular element. So I could count the 5s, which is 2. I could count the 4, which is just 1. I could count something that is not there. Okay, but in that case, so since it's not there, it's 0. Okay, and pretty much that's it. So count will return the number of occurrence of that particular value. Okay, you also have extend. Extend will basically make your list larger. So if you are going to create or to expand your list, okay, say I have an existing list. So my list, okay, my list will be initially, say, 2 elements, say mango and apple. Okay, and I want to make it bigger. Okay, I want to make it larger, for example. So current my list. So all I have to do is to append the values. So my list, okay, that append. So if you are going to append, you're appending just one value. Like if I want to append an orange, okay, you could do the repeated. You could repeat this for multiple times. However, you could simply extend. So extend, okay, will allow you to add multiple elements. Okay, like say want to add so these fruits, maybe peach. Okay, dragon fruit. So you could add multiple items at once, and you have the new list now. Okay, will be created. You could also do, if you recall the sequence operation, you could also use the concatenation. So my list, okay, could concatenate with a plus. So we will add maybe mm, okay, let's just use letters. Okay, uh, ran out of fruits. So alpha. Okay, so you could do append as well, or concatenate with the overloaded plus sign. So that's a way to extend. You could use the extend function, or just use the concatenation. You could also check the index. So in this case, let me just repeat. Okay, my list. So you could check the index of orange, for example. In this case, 0, 1, 2. So the index of orange is 2. So you could say my list that index of orange. So again, be careful with Python. This is case sensitive. So if you misspelled the orange with a small o, then it will be an error. Okay, because the start letter is capital O. Okay, so you could also check. That's it for the indexing. So let's have one more example. The watermelon. In this case, okay, the index is 5. So which is the last element in this case? Okay, so that's it for indexing. You could also insert. So if I insert it in the first position, okay, maybe let's recall our list. Okay, how about banana? Let's insert it in the first position. So my list, okay, that insert position 0 and whatever you want to insert. Okay, in this case, banana. And let's just print my list. Okay, so the banana is now inserted in the first position, and we have now our new list. Okay, pop, you could, the default pop will basically remove the last element. So watermelon, okay, if I do not put any arguments to the pop, so my list that, so this default uh, pop will remove and return the watermelon. So it will remove the watermelon from the list. So if I print the my list now, so you don't have watermelon now. Or you could also specify with the pop, you could also specify the item that you want to remove. Like in this case, what if I want to remove mango? So this is in the position 1. Okay. And if I remove it, okay, print the new list. So mango is no longer there, and so on. So you could specify the index, and if you don't specify, the default value will be the last element in the list. Okay, so you could also have remove. Remove will remove the first occurrence of the value. And for example, if I have, so I forgot to mention that a list will allow you to include repeated elements. So if I have my list, I could add apple again, even if it's already in the list. So if I want to add an apple, it will be added to the list. Okay, and if I print my list now, so apple is added in the last element. So if I want to remove something, it will remove the first occurrence of that value. So the first apple will be removed here if I remove apple. So my list that remove, if I remove apple, okay, it will remove the first occurrence. So the new list will be banana, orange, peach, dragon fruit, and apple. Okay, so my list, and okay, indeed the apple was removed, the first occurrence. Of course, if you are trying to remove something that is not there, okay, like what's not there? We have removed watermelon already, and it's not there, not in the list. So this is a value error. Okay, so you could reverse the list. So the way you reverse a list, let's type my list again and reverse the arrangement. Okay, from banana, orange, peach, dragon fruit to apple. We could reverse it to my list that reverse. Okay, and after reversing it, the new my list now will start with apple. Okay, my list. Okay, apple, dragon fruit, and then peach, orange, banana. Okay. This is similar to reversed. I think we have all also tried reversed before for the sequence. But reversed is not in place, so it will not modify the original list. So this will simply give you an object, an iterator of the reversed list. Iterator in which we could utilize to print. Where is that? For I in reverse. Okay. For I in reverse. My list. And then print. Okay. So what's expected here is we're reversing the list. So currently the first one is apple. So it will start with banana. Okay, banana, orange, peach, dragon fruit, and apple. So banana, okay, as expected. Banana, orange, peach, dragon fruit. So again, reversed here will not modify the existing list. Okay, so if you print the existing list, it will still have the order in which apple is first and banana is last. Okay, what the reversed will do is simply return a reversed object. So the iterator for the reversed sequence, okay, of the elements. But it will not modify your list in place. Okay, if you want to modify your list in place, well, you could use the reverse command or method. So in this case, it will reverse it once again. So apple will be last, and so on. So you could repeatedly do this operation to reverse a list. Reverse a list of numbers. So, okay, let's do this. Numbers. Okay, we don't have numbers yet. So let me just create a list of numbers from 1 to 10. So range 1 up to 10 plus 1. So these current numbers are 1 to 10. And in this case, if I want this to be reversed from 10 to 1, so numbers that reverse. Okay, and if you print numbers now, you will have it in reversed order. Okay, sort. You could also sort. The default sort is in increasing order. So currently it's in decreasing order. So numbers, if you try to sort it, okay, that sort, okay, sort will give you increasing order. So let's come up with a random list. Maybe, okay, like say 23, 5, 6, 76, 8, 30, 100, say 34, and so on. Okay, 55. So we have here a random number, and we could try to sort it. So in an increasing number. So our list that sort. So this will modify the list in place. So sort will arrange the numbers from smallest, so 5, 8 to largest na, until 100. So if I print the R list now, okay, you will have 5, 8, 23, 30, 34, 55, 76, and 100. So that's sorting. Okay, stable simply means that it will not change the order if you have similar numbers here, similar keys. Okay, like if there are 55 and 55. So stable sort will not change the order. If the first 55 should come first before the maybe the other number with the same value. So that's just the meaning of stable. Okay, sequence. So sequencing operation in previous video, okay, we have explained in detail the sequence, and the list is part of a sequence. So you could do indexing, and I already explained that in detail earlier. So for example, our list, you could print the first number, you could print the last number, and so on. In the middle, everything in the middle can be printed. So indexing works well. Slicing, okay, slicing works well as well. So the idea, if you slice, like I could choose the first 3 numbers, so until maybe 3. Okay, so 5, 8, 23. In this case, this is already sorted, by the way, because we simply we ran the sort method earlier. So slicing works well. Say, what if I want to slice 34 to 76? So let's try that. 34 to 76. This is 0, 1, 2, 3, 4. So this will be 4, 76. So 4, 5, 6, 7. So this should be 7. Remember that 7 is exclusive. So in this case, 34 to 76. You could also use the indexing to reverse the numbers. So for example, if you have our list, okay, just keep it empty and put a -1 in the step. So in that case, it will be reversed. The order will be reversed. So 100, 76, 55, 34, 30, 23, 8, and 5. So you could do slicing. And in fact, in this case, this is reversing of a list. So you could also try membership. Okay, like in this case, remember our numbers. Or how about my list? Maybe, Okay, we could check whether orange is there in our list. Okay, in my list. And indeed, it's true. You could also check whether a watermelon is there. And in this case, it's false. So membership is possible. Concatenation, so we have shown this earlier. We could concatenate the two lists. Na? Wait, so we killed the REPL. Okay, we could concatenate the my list. So my list will no longer be there. So let's create a concatenation of fruits, maybe mango and orange. Let's concatenate it with numbers. Say 1, 2, 3. As long as they're lists. So it's perfectly fine. And we have a holistic list containing a string and integers. So concatenation works fine. You could also check the length. So if we try to assign this to a list, say this is my new list, I could check the length of my list, and it's 5 elements. You could iterate as what we have seen earlier. So you could come up with a for loop for elements or for item in my list. Okay, it could say print. Okay, the easiest way to go about it. I will print the item. And it will print the mango, orange, 1, 2, 3. You could also get the summation, but in this case, since we have a string, we cannot do it. So summation of my list. You cannot add a string. It will be an unsupported character or unsupported operand. Okay, however, if the elements are numbers, integers, even if it's a floating point, so you can do it. Okay, so in that case, perfectly fine. So you get the result. Okay, so you could also do unpacking and repetition and sorting. So unpacking, say I have here my list. Okay, I want to unpack it with different variables. Okay, so in this case, wait. So this should be an arbitrary number or arbitrary variable. So I could print my A. So the A will contain the first element, mango, and B will contain the orange. C will contain 1, and D will contain 2 and 3. So B, orange, C, 1, and finally D will contain 2 and 3. So unpacking works well. Repetition as well. So if I have a list, okay, like 1, 2, 3, if I'm going to repeat it, say twice, so it will simply repeat the elements. So it will still contain the elements, but the values are repeated, and the order is preserved. Okay, being the new elements are added after the existing elements. Okay, you could also do sorting as what you have seen earlier. Okay, like we could try sorted. Okay, say sorted of my list. Okay, my list. Okay, int and character, because this is just, you cannot you cannot perform sorting for combined strings. In this case, you have data types and integer. However, you could do sorting if it is purely numbers. So like 3, 4, 1, 2. Okay, sorted is 1, 2, 3, 4. Okay, how about if it's purely, okay, if it's purely characters like A, Z, and M. Okay, you could also do it if it is purely characters. However, if you combine them, then there will be problems. Okay, so if it's characters or strings, okay, the sorting will be depending on the dictionary or lexicographic order. Okay, so this will be lexicographic order. Okay, so time for our drills. So in this drill, okay, we're asked to come up with a Python function that accepts a positive integer and returns a list of strings that resembles binary counting. In this case, this will be like 0, 1, and 1, 0, and 1, 1. So in this case, you could come up with a binary of a number using bin command. So say binary of 2. Okay, will give you 0b and 1, 0. And remember that a string is also a sequence, like a list. So you could slice. Like for example, if I want to just retain the 1, 0 here, you could simply do the slicing. Like I only want 0, 1, like 2 onwards, and it will get rid of the 0b. Okay. So in this case, okay, the output is a list. So if I input 0, so if it's negative, I will output a list, or I will output an empty list. So let's define this function. Okay, let's just define a simple function here. So define, say, binary counter. You could also force the user to input an integer. So returns a list of strings that resemble the binary counting. Okay, let's just put this in the documentation. So returns a list that resembles counting starting from 0 up to the input number. So you could just say that, okay, if the type of n, okay, is not int, it could just say, okay, you could just say type error in this case. So raise type error. And let's just input, or let's just inform the user that please input a an integer. Okay, else you could say, or you could just say if type, or if n is negative, okay, let's return empty list. Else Okay, we could just return. In this case, you could use the list comprehension for this. Um, up to n, so 0 up to n. So for I in range 0 up to n, so n plus 1 or n. Okay, so 0 up to n. Remember that the range is exclusive, so you could use n plus 1. And then we could just use the binary of the number. And the binary of the number, we will simply just choose whatever is the second element onwards. Okay, remember that the binary of a certain number, okay, will give you 0b. So we're just getting rid of the 0b in this case. And pretty much this is it. So if I run this one, okay, well then let's test it later. So let's test this one, binary counter with a negative number, empty, with 0. Okay, with 0, it must return as 0. Okay, with 3, 0, 1, 2, and 3. Okay. With 4, okay, 0 up to 4. And pretty much this is it. So this is the solution. Excuse. So you could also have the traditional solution here. Okay, if you're not using the list comprehension, you could also have the traditional solution. Like the traditional solution will give you maybe an empty list as a container. Result is initially empty, and then you could just come up with if n is greater or equal to 0. Okay, then you return this. Otherwise, you return the empty result. Okay, or you could just say result is equals to this. And you only have one return. Okay, but we could try the loop in this case. So instead of the list comprehension, so you could just have a for loop. For some beginners, this is more understandable. So for loop, and then append. So okay, result that append. Okay, append the bin. And okay, bin, and then 2 onwards. And we name this binary 2 using the traditional. Okay, let's run this. And let's try it with negative number just to test. Say negative 1. Okay, it give you empty, which is expected, I believe. Okay. And if you have a positive or if you have 0, okay, it will give you 0, 1, it will give you 2, 3. Okay, it behaves the same as the least comprehension solution. Okay, so that's how you list the binary numbers. And these are the two alternative or two solutions. Okay, not the only two solutions. You could find your own solution. At least these are the common solutions for this problem. So another drill. I believe this is the second to the last. Given a positive digit, write a Python function that will return its rearranged digits. So you're rearranging the digits in a descending order. So for example, you have 87,976 returns a 98,776. So you're just rearranging the digits here. And after rearranging it, it will become the largest value. So in this case, we could use the pattern that we have earlier, in which we were able to isolate the digits. So what you could do to isolate the digits is just to get the remainders to 10. So 8 digits is equals to empty. And we could come up with a while loop. So while n is greater than 0, we will append. So digits that append the remainder modulo 10. And you have to update the n by dividing it by 10. And after this, once you get the digits, all you have to do is to sort. Okay, so we could sort the elements. Let's just print the sorting for now. So print digits that sort, and you could set the parameter here reverse equals to true, because the idea is we are trying to sort it in a descending order. So let's run this and let's try let's try num to max say 1, 2, 3. So 1, 2, 3, we will expect this to become 3, 2, 1 once printed. But again, this is not the complete solution. We're just trying to check if the behavior that we are expecting is happening. So let me run this one first. Okay, reversed. Okay, so wait, reverse. Okay, so in this case, okay, let's not print the sorting. We could print the digits. So it's printing none in this case. So this is also a common mistake. It's printing none because the reverse operation here does not return anything. So for you to be able to to see whether the digits are reversed, you're going to check or to print the actual digits. Okay, like in this case, the 321, which is a list. So the next operation here is to join these numbers, okay, into one integer. And you could do this by iterating. So let's iterate while digit in digits. We could have a result number here. Okay, result number, could try it to be initially 0. And then result is just a sum of these digits. Hmm. So you could have the digits. You could multiply this. If I multiply this with 10, multiply this 10, and so digit times 10. Okay, and the digit times 10 will be equals to the result here. So if we print this, okay, print the result. Okay, print the result. Print the result. So let's just try this one. And we will have, okay, well, digit 4. And there should be a for loop. So for digit in digits. So in this case, so the initial digits, okay, the first digit is 3. So this should be multiplied by 10. And then the result, okay. So this will be powers of 10. And we could repeatedly multiply this by 10 in this case. So digits, let's print the digits first. So print the digit. Okay, so the digits here are 3 times 2. Okay, so what we could do here is we could add. So result, okay, we could add digit times 10. So the initial digit, okay, if I plus add this with digit, so the initial digit will be 3. And then I update the result with multiplied by 10, and we add it by digit. Result is digit plus 10, and then we add. So let's print the result here, because we're just converting the list into an integer in this case. Let's print the result. So the first number here will be 3 times 10 will be 30. And then 30, it should be added with the next digit. So first is 0. So this one, the first is 0 plus the digit. So 0 plus 3 is 3. And then this should be result. So 3, okay, or this will be reduced to times equals. So digit, initially you're adding 0 plus the digit. So 0 plus 3 is 3. And then 3 times 10 is 30. And then next is 30 plus the next digit, so 32. Okay, so probably this will work. Okay, so this works. Okay, but there's an extra 10. So we need to get rid of the extra 10 of the result. So you could just return this result. Okay, and we got our value here. Okay, so let's test our value. Okay, so num to max. Maybe we have 3, 4, 5, 6, 7, 8. So what we expect here is it will return 8, 7, 6, 5, 4, 3. Num to max is not defined. So num to max n. Okay, there. So I'll just get rid of the print. The print is very helpful if you're just beginning in coding. Okay, but in this case, we're using the printing to debug. So in this case, everything is hopefully working. So you could use random numbers, and it will be its greatest. So 98654,332. Okay, so we have successfully came up with a function that rearranges the digits from a number to its maximum value possible. Okay, actually you could simplify this code using more advanced, if you want to come up with an alternative solution. So an alternative solution, so let me call this num to max 2. Instead of coming up with these digits, I could simply convert the list. So digits could simply be converted into a string. So you could have a string of a number and convert it into a list. So this will be the list of the digits. So remember that if you have 1, 2, 3, if you convert it into a string, so string of 1, 2, 3 will appear the same. It will still be 1, 2, 3, but it's already a sequence of characters. But if you convert it into a list, so it will become a list of integer, or it's no longer, it's not yet integers, it's list of digit characters, okay, which is a string. So in this case, okay, we've converted into a list of string, and you could also sort it, okay, the same rule. And for the return, for the result, I could simply join the list. Okay, so join is a string operation. I could simply join it, join the digits. But this will be this will return a string. So if we run this, okay, and you could put 4, you could put 4, 3, 5, and so on. So it sorts the digits. However, the result is a string. So that's the only problem. So you could typecast the result and return it as a string. And this will behave in the same manner as the previous solution. But you're reducing it to 3 lines effectively, excluding the type check. Okay, it behaves the same and it returns an integer. So this is an alternative solution, a simpler one than before. Okay, perhaps this mathematically sound. The first solution is mathematically sound. The second solution is just sort of a hackish solution. You are utilizing the list, the conversion of a string into a list, and joining an iterable into a string. And in this case, we typecast it as an integer. Okay, for our last problem for this refresher, we're going to create a Python function that returns a list that resembles a pyramid shape. So to cut to the chase, the pattern here is like this. Okay, you have this is the first element. So this is the index 0. Second element will be the one with, for example, with 4, in this case, 4 bracket notations. Okay, and so on. So you are going to start with 2 symbols. So in the topmost symbol, there will be a pair. In the second symbol, there will be, in this case, after the pair, there will be 4, okay, alternating. So this is a pair of brackets, and okay, you will be able to set the character, okay, that are opposing to each other. So it must accept the number of lines to generate the character to display on the left half of a single line, and the character to display on the right half of the same line. So for example, if the input requires 5 lines, so there will be 5 elements, the topmost element being the first element, and secondly, thirdly, and so on. So if you notice this, if you arrange this in a sequence with a new line, so this will resemble a pyramid pattern. Take note, you have the capability to set the left and the right symbol. So doesn't have to be a squared bracket, doesn't have to be a curly bracket in this case. It could also be numbers. And the first argument of the function is the height or the number of elements. Second argument is the character that you're going to use in the left side. And the last argument will be on the other side, the character for the other side. Okay, so the default you could set the default to be a backslash or a slash and a backslash. Okay, so let's try this list. So you could just come up with a for loop here. So for I, you could say in range of your, we could set the range as the height, or in this case n. So you could say range n. And let's see. So we define a line being, what's a line here? So the line here is composed of spaces. So in this case, 4 spaces. So if you have a height of 5, 4 spaces, and then you have the 2 characters and another 4 spaces. So 4 spaces, that could be, okay, we could start with 1 here. Okay, that could be, the 4 spaces could be space, remember the sequence, okay, repetition, so multiplied by, this could be n minus I. 4 spaces, okay, plus the left character, okay, multiplied by your I, okay, plus the right character, multiplied by the I as well. Okay, and then you could put this space as well. Okay, which is just the same as the other side. And you could simply append this one with the result. So you could just say result. Okay, result is blank. And I will simply append result that append. Okay, whatever is my line. Okay. And pretty much this is it. So I think we got the, unless we make a mistake, we made a mistake. So let's return the result. Return the resulting list. Okay, control B. And generate the triangle. Let's try this one. Okay, so generate the triangle here. So it gives me the topmost layer is a pair. Okay, so this, I think this works. So you could try this one. You could try this pattern. Okay. So it works. Well, we could also make the printing better or make it more appealing. So I could iterate for line in this triangle. So let me print the line. Okay. Let's print a line beforehand. Okay, just to make it a pyramid form. Okay, and indeed the list becomes a pyramid form. So I could say with like what if this 0, 0 and 8, and let's make it taller, maybe 10. Okay, looks good. So we could change this the other side with another symbol like a squared bracket, and you could just play with this. So this is the idea of creating a list, which in this case the list is composed of um, the pyramid form, the pyramid lines. So the first line being the topmost line, and the last append will be the bottom. Okay, so I think that's it for today. So I hope you learned something. Lastly, just to emphasize the tuple is basically you have a sequence of elements that is very similar to a list, but you cannot change it. So you cannot add elements. You cannot remove elements. But the idea is everything that you could do with a list, like slicing, indexing, and even concatenation, you could also do that with a tuple. Okay, but you cannot change the tuple because one of its property it is immutable. Okay, for the list, however, in my opinion, this is the most commonly used data structure in Python. You only use a tuple if you don't want to change the elements. So tuple is lightweight and it's safer because if you are not subject to accidental modification, just like a list. Just one pitfall of a list, okay, if you came up with an accidental modification. Like for example, if it so happens, okay, that this is one pitfall in a list. Okay, like if you are looping to a list, like you have my list, okay, is for example list of characters. So you have A, B, C, D, or just A, B, C in this case. So if you have a characters A, B, C, and if you have a for loop for I in range or in my list, or for let's just make this for the characters. For character in my list, okay, print I. So in this case, there is no problem here, okay, because you are not, or print the character. Okay, there's no problem here because you are not changing the list. Okay, so the ABC is still there. Okay, but notice what happens if within the iteration you modify what you are iterating. So what if you're trying to append something? Okay, like you're appending and another letter like Z. So if you notice, if I run this, okay, so this actually will give you an infinite loop in this case, or this will give you an error, okay, like what you're seeing right now. So this will give you an error because this is a violation. If you're iterating a my list or a mutable object, then some errors that may occur is you will tend to modify it within the iteration, and that is a big error, okay, because you're not supposed to change something that you're iterating. So that's why you see here an error, okay. So this is an hanging error in this case if it is a ripple in Sublime, okay. But in other IDE, okay, the information here will be more informative, okay. But this is the common pitfall in manipulating mutable objects. Do not change them if you are iterating it, okay. So pretty much that's it, and hope you learned something from this refresher.